Hello, welcome back to week 3. And today we're going to talk about energy analysis, but this time for cycles. Okay, so first of all, what is a cycle? A cycle is a sequence of process that begins and ends at the same state. So for example, if you start from point 1, you go through a series processes and then you go back to state number 1. You start from number 1 and then you add at number 2. But 1 and 2, they're actually the same place. That's a cycle. Okay, so the first thing we'll talk about under cycles is the energy balance. Cycle, energy balance. Okay, we start from first law. Do you still remember first law for a closed system? Q minus W, and that is equal to delta E. This is called the first law of thermodynamics for a closed system. Essentially, this is conservation of energy, which we introduced to you last week. Okay, and now let's continue. Delta E. Delta means change. Whenever you calculate change, it's always final E2 minus initial E1. Okay, so now if you have a cycle, what is the relation between number 1 and number 2? If it is a cycle, number 1 is number 2. So E2 must be equal to E1. So that's why E2 minus E1 is equal to 0. So if we rewrite this equation, we're going to get Q and equal to W. Move W to the right hand side. And then we give it a subscript. It's for a cycle. What it tells you is if you have a cycle, heat transfer must be equal to work. Okay, so that's the first thing, energy balance for a cycle. And then next, we're going to introduce 3 different cycles in this class. The first cycle we introduce is called a power cycle. Power cycle. The reason why it is called a power cycle is because the purpose of this cycle is to generate power, or you can say work. Okay, how do we sketch a power cycle? First of all, you draw a box. That is your system. And then you draw a circle within, meaning it's a cycle. You can think of this box as the engine of your car. How does your engine work? You burn the gas, meaning you provide heat. So we have Q going in, Q with the subscript in, Q in, going into the engine. It's at a high temperature. We use T hot at high temperature. And then what the engine will do is to convert this heat into mechanical work, which you can use to drive your car. So what comes out of the engine is W cycle. Mechanical work comes out of the engine. And unfortunately, you cannot convert all of the Qing into mechanical work. You have to lose some heat. So we call it Q out. The engine will lose some heat, which is really easy to understand, right? Because, for example, what comes out of the engine? The exhaust. The exhaust is really, really hot. So once the exhaust comes out of the engine, it takes energy away. So you must lose some energy. That's why you have a Q out coming out of the engine. Okay, Q out goes to the environment, which is at a lower temperature. We call it T cold. The exhaust goes into the environment, and the environment is at lower temperature, so we call it T cold. Okay, so this is how you sketch a power cycle. And remember, the reason why we call it a power cycle is because the purpose of this cycle is to generate work. So out of the three parameters, which one is the purpose? Yes, this one, W cycle. W cycle is the purpose of the cycle. Okay, next one, let's perform energy balance. How do we do energy balance? Total energy going in must be equal to total energy coming out. That is how you do energy balance for cycles. Okay, left hand side, total energy going in. That is only Q in. Right hand side will be total energy coming out. And then we have two terms. The first term is Q out, and the second thing coming out of the cycle is W cycle. So this is our energy balance equation. Or you can move the two Q's to one side, which will give you Q in minus Q out, and is equal to W cycle. Okay, so this is a power cycle. Okay, so this is how your engine works essentially. Okay, so now if you have an engine, what's the first thing you want to know about your engine? Probably the efficiency. If you purchase an engine, you want to know what the efficiency is. Okay, so we use letter eta. Okay, it's pronounced eta, ETA. We use letter eta for efficiency. The definition of efficiency is always the same. Doesn't matter which system you talk about. The definition of efficiency is always purpose divided by cost. Purpose over cost. Okay, what is the purpose of this cycle? The purpose is to generate work, which is W cycle. You need W cycle to drive your car. And next one, divided by cost. What is the cost? When you drive your car, what do you pay? You pay for the gas. What does the gas give you? Q in. You burn the gas, you provide heat to the engine. This heat is Q in. So this is what you pay, Q in. Okay? And now if we rewrite W cycle from this equation above, what we have is Q in minus Q out divided by Q in. So my solution is 1 minus Q out over Q in. Both of the two Q's are positive, so the second term in the right-hand side is positive. 1 minus something positive, that must be less than 1. So our efficiency will always be less than 100%. Okay, do you have a general idea about what is a typical efficiency for the engine of your car? You can make a wild guess. The efficiency of the engine in your car is usually around 40%. Usually for any thermal system, the efficiency is around 40%, which is really, really low, isn't it? And then later on, when we study second law of thermodynamics, you will realize there's no way for you to go above this number. It's just not possible because it violates the second law. Okay, so that's the first cycle we introduced today. It's called a power cycle. The next cycle we introduced today is called refrigeration cycle. Okay, refrigeration cycle. How does refrigeration cycle work? First of all, we're gonna sketch the cycle just like before. You sketch a box indicating this is your system, and within this box, you draw a circle indicating this is a cycle. And then you can think of the refrigerator in your home. And how does it work? First of all, you provide what? What does the refrigerator consume? You have to provide the refrigerator with electricity, and electricity is one form of work. So what we have is you have work going into your system, going into your system. And then how does the refrigerator work? How it works is to grab the heat from the cold inside and then release the heat into the warm environment. This is how a refrigerator works. It transfers heat from low temperature, which is inside of the refrigerator, to a high temperature, which is the warm outside. Okay, so you grab heat from the inside. The refrigerator will absorb heat from the inside, which is at a lower temperature. We call it T cold. And then releases this heat, we call it Q out, to the warm environment, which is at a higher temperature. So we call it T hot. This is how a refrigerator works. Grabs heat from the cold temperature inside and releases heat to the warm outside, T hot. So you can see here, heat transfer happens from cold to hot. This will not happen unless you pay. What do we pay? Electricity, which is work. Okay? All right, so let's do energy balance again. How do we do energy balance? Total energy coming in must be equal to total energy leaving. Okay, so let's do left hand side first. Total energy coming in. How many terms do we have coming in? We have two. Q in goes in. What else goes in? W cycle goes in. So left hand side, total energy going in must be balanced by the total energy leaving. Total energy leaving, there's only one term, which is Q out. And then what you can do is to move all the Q's together. So that's going to be Q in minus Q out. Oh, no. It's going to be Q out minus Q in, and that's going to be W cycle. Okay, so that's the first thing we did. Energy balance for refrigeration cycle. And next one, just like a power cycle. If you have an engine, you want to know the efficiency before you make a purchase, right? And now, when you buy a refrigerator, you probably want to know the same thing. What is the efficiency, right? How good the performance of this refrigerator is. So we do have some parameter that we use to evaluate the performance of the refrigerator. Just like for a power cycle, what we used was called efficiency. And for refrigeration cycle, we have something called coefficient of performance. And we use beta. We use the letter beta. And what is the definition of beta? Still the same. Purpose over cost. Purpose over cost. And now some of you may ask, if the definition of efficiency is purpose over cost, and here beta has exactly the same definition, why do we give them different names? So for example, the first one is called efficiency, and now it's called coefficient of performance. If they have the same definition, which is purpose over cost, why do we give them different names? The reason is because for efficiency, based on our equation, the solution will always be less than 1. And then when we move on to refrigeration cycle, you will see beta is possible to go above 1. So to avoid any confusion, we give beta a different name. We call it coefficient of performance, only because the value can go above 1. So that's why we do not call it efficiency, even though it does have the same definition as efficiency. Okay, so let's do this definition. Beta, purpose over cost. What is the purpose of a refrigeration cycle? Or in other words, what is the purpose of your refrigerator? What is the purpose of a refrigerator? It is to keep inside cool, right? So out of the three parameters, Q out, W cycle, and Q in, which one is the direct reason that can keep your refrigerator cool? If you want to keep your refrigerator cool, you have to take away the heat released by the food. Which one is taking away the heat from the food inside? Q in. Q in is the heat released by the food inside. So to keep it cool, you have to take it away. Take it away, that's Q in. Okay, cost. What do you pay for the refrigerator to work? We pay electricity, and that is W cycle. And now we can rewrite W cycle from this equation above. That's gonna become Q in divided by Q out minus Q in. Okay, and the value can be above 1. The value can be higher than 1. That's why we do not call it efficiency, but coefficient of performance. So do you want to have a refrigerator with a big beta or a small beta? Of course, you want a refrigerator with a big beta because you want the purpose to be high and you want the cost, which is the denominator, to be low. So that will give you big beta. The bigger the beta is, the better the performance is. Okay, so that's the second cycle we introduced today. It's refrigeration cycle. And then the last cycle we introduced today is heat cycle. Heat cycle. Okay, how do you keep your house warm? First thing again, we sketch the box indicating this is my system. Next one, we draw a circle inside, indicating this is a cycle. Okay, let's do it again. How do you keep your house warm in winter if you have central AC? How does the central AC work? How does it make your house warm? So first of all, you have to provide the central AC with what? What does it consume? Electricity. So you provide electricity, which means the system consumes work. So we have work going inside the system because the system needs electricity, the work. Okay, how does your house keep warm in wintertime? You provide electricity, and then what's gonna happen is the central AC will grab heat from the cold outside and then release this heat into the warm inside of your house. So grabs heat. The system grabs heat from the cold outside. So T cold. And then releases this heat, Q out, to the warm inside of your house, which is at a higher temperature. We call it T hot. So this is the cycle and how you sketch it. All right, and then we can do the energy balance again. Let's do the energy balance again. Okay, Total energy going in, which is Q in plus W cycle, must be balanced by total energy coming out, which is Q out. And then we can move things around. Q out minus Q in must be equal to W cycle. Okay, so that's energy balance for a heat cycle. The next thing we're going to repeat, we need to evaluate the performance of this heat cycle. Right? How good is the performance? We use something similar. It's called coefficient of performance. And this time we use letter gamma. We use letter gamma, coefficient of performance. And what is the definition of gamma? You guessed it right. It's exactly the same. Purpose over cost. Okay, so what is the purpose of a heat cycle? So in other words, out of the three parameters, Q out, W cycle, and Q in, which one is the purpose? Which one is the direct reason that keeps your house warm? In order for your house to stay warm, you need to give it heat. Which one is the heat going into the house? That is Q out. You release this much heat into the warm house. So this is the purpose of a heat cycle. And then what is the cost? The cost is electricity. You pay electricity. So that's W cycle. And then we can rewrite W cycle from our energy balance equation just like before. It's going to be Q out minus Q in. And gamma, just like before, just like beta, can be above 1. The value can go higher than 1. And again, that is the reason why it has a different name other than efficiency, even though it does have the same definition as efficiency. We have to give it a different name, only because the value can go above 100%. Okay, so that's the third cycle. And now, maybe some of you have noticed, if you take a look, the top one is the refrigeration cycle. Take a look at the diagram. And now, take a look again at the heat cycle diagram. What do you notice between those two diagrams? Those two diagrams are exactly the same. They have exactly the same diagrams. And then you may ask, if they have the exactly the same diagrams, why do we have different names for each one of them? The top one is called refrigeration cycle, while the second one is called heating cycle. Why is that? The reason is they have different purposes. What is the purpose for a refrigeration cycle? Q in. Q in is the reason for the refrigeration cycle. Q in here is the reason for a refrigeration cycle. And then if you move on to a heat cycle, what is the purpose of a heat cycle? That's different. This time it's Q out. Q out is the reason for a heating cycle. So that's why even though they have exactly the same diagrams, they have different names because they have two different purposes. So now you may understand why for a central AC, it works for refrigeration and heating too at the same time, because essentially they're the same thing. Okay,